Alright, welcome back to C# scripting tutorial series in Unity. I am Andrew with webgardener.com, and this is part 2 of the classes and game objects tutorial. We're just going to jump right into it. So last time we talked about what game objects are, what classes are, what the differences are, and so on. So this time we're going to jump into the code. So I've created just a basic new scene. There's nothing in it other than a main camera and a directional light. But this time we're going to go ahead and create a cube and go ahead and reset the origin for it in the transform. So we've got our cube here, and what we want to do is we want to create a script which is also a class, because that's how Unity understands this. So the easiest way, we'll do add component, we'll say new script, and you can see this is going to be in the C# language. So we'll just call this rotate object. And right there you can see here's our script. And this grays out because the compiler has had a chance to read through this and look at it and make sure that it is what it expects it is. Let's jump into the script itself, and I'm just going to load this in MonoDevelop since not everyone has Visual Studio. And MonoDevelop came with it, so that's pretty easy to work with. Alright, so right here we can see we have defined our class. Now in this case we have a public class, which means that the public says this is now visible to all other aspects of Unity. Any other classes we create, any game objects that we have or things like that can see this class that we've defined called rotateObject. And of course this just tells us that it's a class. Right here, the little colon there says rotateObject inherits from MonoBehavior. And MonoBehavior is a class which Unity has developed for us. And what MonoBehavior does is it gives our class the ability to see all of the components that this object has inherited from. So transform, the mesh, the collider, the mesh renderer, anything else we were to add to it, that MonoBehavior basically links it up for us so we can look at this and say, okay, cool, well, I need to grab a hold of the transform of our object that rotateObject is attached to. So our cube is inheriting from rotateObject, which is also inheriting from MonoBehavior. So with that in mind, let's go ahead and make this do something, because obviously that's the whole point of it. How does this work? Well, first thing, get rid of that just to kind of clean up our code a little bit. And here in the update function, which you can see the notes automatically help us, update is called once per frame, we're going to go ahead and do something with this. So we're going to call this, which you can see right here, it says this keyword refers to the current instance of the class. So we're actually referring to this instance of the rotateObject class. But again, remember, we're inheriting from MonoBehavior, which means we can access anything inside of here as well. So this .transform means that we are accessing this right here, this component up in the top. So our position, our rotation, and our scale. Okay, so transform is being defined for us. So we are now accessing the position, rotation, and scale of this. And we're going to go ahead and do something with it. Let's rotate it. And we're going to feed it a vector 3. We'll use a predefined vector 3 up. And you can see this is the shorthand for writing 0, 1, 0. Now, in order to actually get it to do something, we're going to do time.delta time. Now what this does is this looks at how long has it been since the last frame was called. Multiply that time by our 1, which is in the up Y direction, right? And that's going to tell us, okay, rotate that amount of time around our vector. Well, here's the problem. This amount of time, depending on your computer, could be 0.00001 second. That's not going to be very quick at all. So let's go ahead and make it easier so we can see something. We're going to rotate it by a rotate speed. So let's go up here and we're going to say this is a float value called rotate speed. And there it is. Now, one more thing we need to do real quick is we need to make sure that we can access rotate speed. We're going to say public. Now what this does is because rotate speed variable is now public, that means when I save it and I come back to Unity, the inspector will compile it and see that that public variable is now exposed. So now when I hit play, you can see it's rotating, but I could also just come right here and say, all right, increase that speed. You know what? Let's make it even faster. Or let's slow it down to say 500. Or we could go -200 and rotate the other way. So you can see how that gives us a quick access to it. Now, technically, exposing a variable using the public isn't really good practice in programming, and I'll explain why when we get into the next video, which will be variables and data types, how to define them, how to utilize them, and some of the best practices. One last thing I want to define here is I want to explain something very important, which I think is often overlooked or misconstrued incorrectly. When you define a class to be used in Unity, it does not have to have mono behavior. But you can actually just define a class, and call it my class. And right there, we have defined a class. Now, can I access things like transform and things like that? Well, the editor says I can, but I won't have any local transforms that I can access. See, I don't have a lowercase transform there because I'm not inheriting from mono behavior. So a lot of people ask, well, then what's the point of that? Well, maybe we're making a role-playing game and we've got a whole bunch of items and objects and things that we want the user to have access to. So in that case, we can define things like, string, object name. It could carry things like int for damage. Maybe we're defining, weapons or things like that. We could have a float for its weight, and so on and so forth. Well, these by themselves, basically this class is now a box that just contains information. And we could come up here into our object class and we could say, okay, well, you know what? I want to create a list of my classes, and these are going to be weapons. Equals new my class. Boom. And so now what we've defined is we've defined a class which can only be used if one of the other classes, which we can access in our scene, which is inheriting from mono behavior, so the editor and everything can actually compile it and include it with our scene, and then that class can then call other classes that aren't included in the scene specifically. So thanks again for watching, and I will see you next time when we cover variables and so forth. And again, if you like my videos, please hit like, subscribe if you want to catch up on all the latest videos of tutorials and other things that I like to do. And once again, thanks for watching.